Okay everyone, we're back with another video. In this video we're going to look at I suppose a couple of videos, and we're going to look at some isolated tasks, particular procedures when we need to use particular methods to solve, I suppose, isolated tasks, small tasks within the system that we're looking at. Okay, and in this video we're going to look at counters. So counters obviously count events for us, but they can be a little bit tricky to use. Okay, so we've got to keep in mind a couple of things when we're using counters. So if we just quickly look and try and refresh our memory on what the counter block looks like, we use a CTU, and it's got a CU, or input, that we're going to count. We have a Q, the output, when we've reached a count. We have the reset, which is important, and then we have the PV and the CV. So the PV just sets the value of our counter. The CV is the value of the counter at any moment in time. We don't use it usually to use with HMI screens and things like that. Now, the important part that we need to remember with a counter is that on this side we get a latch-in output. Okay, that if the count value is reached here and we get an output on Q, it's going to stay latched on even when we drop the input, and it's only when we reset the counter is when we'll lose that output. And that can bring its own advantages and disadvantages in its own right. But mostly when we're using the sequential integer method and we're looking to move through steps, this can be dangerous if we leave a move command in here. If we leave a move block connected here and we say, let's say, once we reach the count, move to step 50, that will cause us issues. Okay, so that's not what we want to do. But you know, when you're kind of thinking about this and you're writing it out, it does kind of make sense, and it's a trap that most people fall into, because we essentially want to say, yeah, keep counting something, and when we count it, move to the next step. But the problem is, if you do that and you move to the next step, within the next step, say equals to 50, you know, you're going to say something happens, and then you're going to move to 60. Okay, and then when you move to 60, this is never going to happen because this is still latched up here, and it's going to move you back into step 50, so you get stuck in like a loop, and it can be hard to get out of that, because you might be saying, well, why don't we reset it appropriately? But if you try and reset it when you're in step 50, you can't use the same thing that you create on the output to reset it. It gets caught. You can't use the same thing to kind of create your output that you're using to break your output. You know, it doesn't work. So you get stuck in this endless loop. So we've got to use something else in here that is okay to be latched on and won't affect us, and then we look at using a reset more sophisticatedly or more appropriately down the line. So that's really the counter. That's the main issue with the counter, or not really an issue. Well, you know, main trap with the counter. The main thing we got to keep in mind about when using a counter that has a latch-in output, and that we don't want to use the move block in there. We want to use something else, because we leave the move block in, it stays latched on, and even if we try and go past then step 50 in this example, we then get moved back to step 50. It keeps kind of getting caught in that loop. Okay, so I'll just pause it for a second and we'll look at the example. Alright, so let's take an example. Alright, let's just say we want to count, we have a plus, then it's a minus, and we want to count this. Okay, let's go 5 times. Alright. Generally, my sort of rule of thumb is if it's a count of 2 or 3, I write it out what I call kind of the long simplistic way. If it's more than that, if it's, you know, 4, 5, 6, 7, we want to use a counter because we want to shorten it down and do it a more advanced way, okay, a smarter way. But sometimes, if the count's low, there may not be a need to actually use a counter for these type of examples where we're kind of watching this movement go in and out, and we have sensors to track that. Okay, so let's talk about this, right? And I'm going to split my table into two here, and really we're just going to have a look at the output side, and we're going to have a look at what happens on the input side. Okay, and this would be kind of similar to what we would do anyway. We maybe have our input side in a function block, and our output is in the OB1. Okay, so our input's in some sort of function. Okay. So let's just take this from the get-go, right? As I said, this could be part of a larger system, but let's just take it from a real simplistic view. So let's say equal to step 0. We press the start button, and we go ahead and we move to 10. Okay. So in step 10, A is going to move forward. So we have A extend, and what we're going to have is equal to 10, bring A forward. Right? Then we have in step 10, I'm going to check that A has come forward. So we have AL1, and we move to step 20. So in step 20, what we're looking to do then is bring A back. So we have A retract, it's like a double solenoid cylinder. And then we want to check that A has come back. Okay. ALO. And that is one pairing that we have. Now essentially we've got to do this, and actually, you know what, I'm going to change this to 3. We've got to do this, that's one count. It's gone forward and it's come back. Essentially I've got to do this 3 more times to get my system to work. And if I was writing this out the long and simplistic way, I would simply just repeat this another 2 times, this pairing. Okay, so we would move to 40, then we put in an OR gate here equal to 40, bring it out again, then we'd say in 40, wait for it to come back, move to 50, oh sorry, made a mistake there, it should be 30, bring it forward, see there, 30, bring it 40, wait for it to go forward, then go to 40, 40 will bring it back, then that's another pairing, so that's our second count, and then equal to 50, bring it forward again, AL1, move to 60, so we'll have it here, equal to 50, move it forward, and then in 60, wait for it to come back, and move to 70, say we're going on to do something else. Okay, and then we have that there, equal to 70, bring it up, bring it down. And that's essentially what we have if we're writing it out the long way. We have a lot of OR gates that comes into the output, and we essentially have a long repetitive code with all these pairs. Okay, and that can be quite straightforward to do, and as I said, if the count is only 2 or 3, you might want to write it out like this. You can copy and paste that quite easily, change numbers, and it's not so bad. But let's say our count's larger, it can maybe be a wee bit tedious to write that out the full way, and then our outputs get quite large in here. Okay, so let's look at it with the counter setup and how we would do that differently. Okay, Again, we're looking at a plus, a minus, and let's say we'll give it a count of 5 here. Alright, and likewise we'll look at it in terms of the two sections. Our inputs in our kind of function block, well, and function, not a function block, and we'll look at our outputs, which we sort of deal with in our OB1. Right, so the way we deal with this is still in a similar fashion. We still got to set up a pairing. Okay, so I'm just going to leave myself a wee bit of space here. So we still got to set up a pairing. Well, actually, let me just put in, just for completeness sake, let's do the start, and let's do our move to step 10. Okay. Now, as I said, I got to set up my pairing. Okay, so if I'm equal to step 10, I still have to wait till I hit AL1, and then I gotta move to 20, and then equal to 20, I gotta set up my ALO, and then I gotta move to 30. And on our output side there, we will equal to 10, extend our cylinder, extend, and if we're equal to 20, we'll retract our cylinder. Okay, so I still need that to happen, but now what I want to do is I want it to be repeatable. So I've obviously got to put in a counter. That's what we're looking to do. So we'll put in our counter. It's a CTU counter, and we've got to give it a name. I'll just call it counter 1. So it's like a timer. You got to give it a unique name each time. Make sure it's a different name each time. Even if you're only counting the same value, you got to give it a different name each time. We've got PV and CV. CV doesn't need to be connected to anything. PV we want to count 5 times. We've got a CU and we've got a Q. Okay, so CU we want to count an event, and the thing we want to count is AL1 when it extends. But what we only want to do is we've got to put a number beside this as well, an integer, because we only want to count it when we're in step 10. We only want to count that input when we're in step 10, because that input could be triggered at other times throughout the sequence, but only when we're in step 10 is it part of our counter. Okay, so in step 10, count AL1, and what happens is, and also we'll have the reset in here, which we'll talk about, when we reach our count, we don't want to put a move in here. Okay, that would be wrong. What we want to do is we want to use a memory bit. So we've got to create a memory bit in our tag table that will call it, maybe, I don't know, count reached. Okay, and this memory bit will help us make the decision on whether to repeat the cycle and go back to, say, step 10, or go around and come to step 30 and exit it. So we use this count reached input to now make the decision to say, do I need to go back around the cycle or do I exit it? Okay, so how we look at that then is we can say, well, in step 30, check if, you got to give us two options. If my count reached is on, we are going to go into step 40, and if it's not reached yet, we will move back to step 10, because we can then repeat the pairing again. We go back into step 10, both these lines will be active because we're both in step 10. It will trigger AL1, it'll count AL1. We see here in step 10 it'll move it forward, then it'll go to step 20, it'll move it back, and then we ask the question again, has your count been reached or not? If it hasn't, go back and repeat that pairing again. And that ultimately is our counter cycle. And it will do that pairing until it reaches 5. And then once it reaches 5, this output will be on. And then when we come to step 30, it will say, yeah, the count is reached, so don't continue this cycle, and move us into step 40, and then that's fine. And you can see our output side becomes nice and condensed. Our input side still takes a couple of lines, but maybe not as many lines if you had to write this out in all the pairings. Now the only thing that's left is the reset, and I'm going to try and just bring this over here a bit. With our reset, we usually have two OR gates. We want a manual reset and an automatic reset. So the manual reset could be from a reset PB, that just if, let's say, the system was running and we only got 2 or 3 counts and we had to stop the system at some stage, we might use a stop button or a reset button to reset our counter back to 0 so we can start again. But the manual part of that reset is important as well, and we'll have it with an equal to number. And when we want to reset it is down here in step 40. So when we get into step 40, we can reset our counter. And the benefit of that is we're not using the same thing over on the left hand side to, kind of activate the output, then to break it. We're using different setups. Okay, we're using a ladder step. So the count gets reached in step 30. Well, actually, the count could well be reached in step 10 at some stage. Moves into step 20, make sure it's retracted. Then it checks, okay, have I done all my steps? Then moves us into 40, and we can reset that counter back to 0. So that, I know I've kind of squeezed it in here on the left, that is sort of our setup. We have the way we start the counter. We still have one pairing. Then we bring in our counter. Make sure you have the equal to. You only want to count it at a particular integer. You've got to create a marker, memory bit in your memory bit table. It's a percentage %m tag. You set your value for your counter. Then you make up this query that basically says, has the count been reached or not? If it hasn't, go back to the start, or if it has, exit and on to the next step. And then for your reset, you need a manual reset and an automatic reset. Usually the automatic reset comes down here from when we're finished with the counting cycle. Okay, so I hope that makes sense in both circumstances. Whichever one you want to use is perfectly fine, but I do recommend if they're looking for high numbers here, to use the counter, and if it's low numbers, maybe use the long number. So I'll do it in the code. It'll be a quicker video. I'll do it in the code, and that'll just complete this section.